In this video, I'm going to show you how to use these charts that I'll show you in a second to answer Chinese remainder theorem problems where there's three conditions. So this is a fancy way of saying find a number that if you divide by 3, you get remainder 2. If you take the same number and divide by 5, you get remainder 3. And if you take the same number and divide it by 7, you get remainder 2. And there are infinite numbers that make this true, but there is a smallest number. Why don't you push pause and think about what do you think the smallest number? It is less than 100 that makes all three conditions true. You can pause. Okay, welcome back. Did you guess that the number was 23? 23 divided by 3 is 7, remainder 2. 23 divided by 5 is 4, remainder 3. And 23 divided by 7 is 3, remainder 2. Well, in order to understand the process I'm going to teach you for solving questions like this, they can get a lot more difficult. Let's start with 3 facts. It's a fact that 70 divided by 3 gives remainder 1. It's a fact that 21 divided by 5 gets remainder 1. And it's a fact that 15 divided by 7 gets remainder 1. Those are 3 things I think we'll all agree are true. Now look at this big 16 number expression I'm about to write. Let's examine this thing. This is maybe a big number, maybe a small number, but 2 times 2 times 5 times 7 plus 3 times 1 times 3 times 7 plus 2 times 1 times 3 times 5 minus 2 times 3 times 5 times 7. Just want you to look at this thing and consider what would happen if I took this giant number and divided it by 3. Well, if that happened, see the 3 right here in this second term? The second term has a 3, actually has 2 3's in it. So it's not going to affect the remainder because that piece has remainder 0 when you divide by 3. But these other 2 pieces also have 3's in them. So the only thing that really matters in determining the remainder when this expression is divided by 3 is the very first term, this 2257. But notice the 257 is actually like this 257. So without this 2 in the front, it would be remainder 1. But if you double it, you get 140, which is going to be remainder 2. If you double something that gives remainder 1 when you divide it by 3, or even simpler, if you take 10 divided by 3, you get remainder 1. But 20 divided by 3 gets remainder 2. So this 2 in the front means that it's going to be remainder 2 when I divide by 3. On the other hand, if instead of doing mod 3, I did mod 5, then this has a 5 in it, this has a 5 in it, this has a 5 in it. So those terms don't contribute to the remainder. The 137 is kind of like this thing. It's remainder 1 when I divide by 5, 21. But this 3 in the front turns that remainder 1 into remainder 3. So the answer would be remainder 3. And if instead I were to divide by 7, this has a 7 in it, this has a 7 in it, this has a 7 in it. So all that would matter is this remaining term. But the 135, that's 14, which is remainder 1 when I divide by, that's 15, which is remainder 1 when I divide by 7. This 2 in front turns it into 30, which is remainder 2 when I divide by 7. So it would be remainder 2. And just so you know, this big expression is actually equal to 23, which is the answer to this warm-up question. So the question is, how would I produce an expression that looks like this? Well, let's take a look. We're going to need some tables coming up, but for now, maybe I need a little smaller. 1, 2, 3, 4, plus 1, 2, 3, 4, plus 1, 2, 3, 4, minus 1, 2, 3, 4. The question I'm trying to solve is x is equal to 2 mod 3, x is equal to 3 mod 5, and x is equal to 2 mod 7. Okay, in the first term, I'm going to put, so we have the three things I'm dividing by. In the first term, I'm going to leave off the 3. So I'm just going to put the 5 and the 7 here. In the second term, I'm going to leave off the 5. In the third term, I'm going to leave off the 7. And in the last term, I'm not going to leave off any of them. Now, let's deal with the remainders. In the first term, I'm going to put the 2 here from there. In the second term, I'm going to put the 3 from here. In the third term, I'm going to put the 2 from there. Fourth term, I'm not going to fill that in. So I actually have all but 4. I have 12 of the 16 things filled in already. But now the trickiest part is these 3 numbers, and then also this fourth one that's gotten a different way. When I divide by 3, this eventual answer, these 3 terms aren't going to matter because they have a 3 in them. So this first term is the one that's important for dividing by 3. I want to get remainder 2. That's why there's a 2 out here. So what I need to do is put a number in here, in this box here, so that if I multiply it by 5 and 7, by 5 times 7, by 35 that is, it gets remainder 1 when I divide by 3. And that's where the charts come in. I come here, and in this chart, I find the chart for n equals 3, and the other 2 numbers are 5 and 7, so I find the 7 and the 5 there. Use the bigger number from the in the column from the bigger one and the row for the smaller one, and I find their intersection, which is 2. What this means, that 2 in that spot, means that 2 times 5 times 7 is equal to 1 mod 3. And it is. 7 times 5 is 35, times 2 is 70. 70 divided by 3 is 23, remainder 1. That 2 is what goes in this spot right here. Now for this next one, I go to this. That first one was for the 3. This next one's for the 5. You see these other terms all have 5s in them, so they don't matter for the remainder. I go to the n equals 5 chart, which is over here, and I take the 3 and the 7, and I look at what number's there, and there's a 1 there. That's because 3 times 7 is 21, which is already remainder 1 when I divide by 5. This number here is what you'd have to multiply all 3 of these numbers together in order to get remainder 1 when I divide by 5. And that's why I put a 1 here. And this third term, is for the when I divide by 7. So I have to go to the n equals 7 chart. And I take the 5 and the 3. And you see how there's a 1 here? That means that 5 times 3 times 1 divided by 7 is remainder 1. This number here is not the remainder. It's the thing I have to multiply by to get remainder 1. I'll say a little more about this chart in a second. And that's why I put a 1 here. Now at this point, I can actually work out what these numbers are individually. This is 140. This is 63. This is 30. And they add up to 233. A couple of things I want to say now. 140 is, if you divide 140 by 3, you will get remainder 2. If you divide 63 by 5, you'll get remainder 3. And if you divide 30 by 7, you'll get remainder 2. But that's also true for the number 233, because if I divide 233 by 3, these two terms aren't going to contribute to the remainder because they already have their multiples of 3. So only the 140 matters. So 233 is actually an answer to this question, but it's not the smallest possible answer. If I subtract away 3 times 5 times 7 is 105. If I subtract away 105 from this, I get 128. That's also going to have remainder 2 when I divide by 3, remainder 3 when I divide by 5, and remainder 2 when I divide by 7, because all I did was I took away 105, which is a multiple of all three of those things. But it's still not the smallest. If I take away another 105, I get 23, which is the smallest answer. But to do it in one shot, you can take the 233 divided by 105, and you get 2 remainder 23. The 2 is what goes here, and the answer, the remainder, is going to be the answer. And that's how you do Chinese remainder theorem with 3 conditions, but you need to have this chart. Just want to say a little more about this chart. I'm just going to pick like a random, like a weird number here, like that is a 7. So that 7 means that if I multiply 5 times 3 times 7, which is actually the 3 numbers from before, 105, it means that 7 is the right number. You can check by dividing 105 by 13, and you get 8, 104, remainder 1. So you could actually check that these work, and I could, I suppose, like make a thing where I erase a number and say what number should go here. I'll do one of those now. So let's say this number just wasn't there, and I wanted to figure out what number should go there. I go 13 times 5 equals 65. Actually, yeah, okay. And 65 divided by 7, I cross my fingers and say maybe that's has remainder 1, but it doesn't. It's 9, remainder 2. So it's not going to be a 1 there. If I double that and take 130 and divide that by 7, I get 1, 8, remainder 4, so it's not going to be a 2 there. But if eventually I do 7 into 260, which is 13 times 5 times 4, I get 3, 5, 7, remainder 1. And that's the reason that there is a 4 here and not a 3 or a 2 or a 1, because it's true that 13 times 5 times 4, namely 260, divided by 7 gets remainder 1. So the thing in the chart is the thing you'd have to multiply all three of these numbers together so that when you divide that product by whatever the chart's for, you'll get remainder 1. And we need that because that way we get remainder 1 here, but the 2 in front turns it to remainder 2, and I get remainder 1 here. The 3 turns it to remainder 3, and I get a 1 here, and multiplied by 2, I get remainder 2. And that's the process for answering this question. And that's why we get 23 is the answer, and that can be done for more complicated problems also.